There we go. Audio. Beautiful. All right. How's everyone doing this evening? In just a second, we'll get into some coding or something. Sure of it. All right. Let's get going. That's awesome. Let me get my hair done, and then we'll get started. All right. So I had to do a little research. I was going to do some stuff over the weekend, and I know that I had kind of said that I was probably going to stream some on Saturday just because I was getting some work done. And that's kind of what this stream is. Whenever I'm getting some open source work done or whatnot, I'm just going to stream it. And, anyways, it turned out we had some pretty bad tornadoes go through, and I tried to do what I could to help, but also just, yeah, wasn't in the mood at that point to do any work. So yeah, didn't do any work, but I did do a little reading, and that helped me figure out what was wrong with our bit array. So if you remember, we were like, "Oh, this is easy," and then like got halfway through it and spent another half hour trying to understand how to make a byte array in Rust, or a bit array, not a byte array, a bit array. So yeah, that being said, let's go ahead and look that up again. And I'll show you guys what I read. And yeah, let me just turn my computer on. Sorry, I got a little bit of a late start. For any of you who are new here, forgive me. This is horrible code, and I know that, but I'm learning Rust. And so I hope that you can find it in your hearts to forgive me for the horrible code. That's, yeah. All right. All right, so this is the code here that we had. And basically, what we wanted to do is this is basically what we had after the first cycle from this. But this is just numbers, and we needed to actually make this a byte array from these. And so what I found was that, let's open up Chrome here. Let's open up a new tab in Chrome. Uh, bit array in Rust. There's actually a external library called the bitvec, or it's a bit vector. And so I think we actually have to use this. There is no inbuilt way to deal with bits in Rust. So this is what we're going to do today, and we're just going to play around with this for a little bit as we learn Rust. If we get to doing the advent of code and finishing that, that's great. But I'm very interested myself in just understanding this a little bit better. I know on our day to day, we don't ever really deal with bits, so it probably doesn't even matter that much. I could probably use Rust effectively without ever knowing how to use bits. But I don't like being defeated. And you know what? Thursday, I kind of felt defeated. So we're gonna do this today. And if you want to join me, that would be great. Feel free to chat and talk. We can also do some stuff. I actually had a great recommendation today by a friend who said we should set up some way to basically. There's this service called Restream.io, but it's super expensive. And he had an idea for a way to basically do it for free on some free tiers. And maybe we'll try doing that as well as one of our projects. But right now, we're doing a bit vector. Let's see if we can't get this to work. All right, so in this we need to basically do this dependency. Let's do that really quickly. How is everyone doing today? Hopefully well. Hopefully well. All right, so we're just gonna throw this in here. Copying and pasting, one of my best skills. Well, that didn't work. Why does it oh, that's interesting. It's deleting it. And I'm assuming it's because oh, this is in the cargo lock. Oops. Yeah. Okay. I'm an idiot. You gotta be in the cargo, the TOML, not the lock file. I was like, it's weird. It keeps deleting it as soon as I save it. That's because you're not supposed to be touching that file. All right. So, hey, Jabril, it's nice to see you. I'm surprised that you're up. It's like super early morning for you. Maybe that works well. So basically, last Thursday, we kind of left on a bad note. I felt a little depressed because we hit this. It's working with bits, and Rust doesn't have a native way to work with bits, and I didn't know that. And basically, we kind of I just like wrote some crap for like an hour and didn't really know. And then I didn't stream on Saturday because there was a bunch of stuff that happened on Saturday here in Kentucky where I live, and didn't feel like streaming at the end of that. So yeah, so basically we're learning Rust. And one of the ways that I like to do that is just some good old coding challenges. And so we were doing the advent of code to learn Rust. That was kind of my way of saying, hey, we're probably only going to get up to like day 15 or 16, but we'll see. I'll probably finish the advent of code. It will just probably be like the end of January or February before we actually finish it, because I'm not too hard pressed in doing it the exact same day. So we're on like day 4. Anyways, or day 3, actually. We're on day 3. Because this one kicked my butt. Again, there's no native bit. So what I did find was there is this library called BitVector. So the Rust standard library has no way to manipulate bits. It is 2 a.m. for you, Jabril. You should be going to bed. That's not a sane time. Maybe at some point I will also stream in the morning, like before work. I don't know. I am taking this for fun, so like, we'll see. But yeah, so there's this BitVect, and yeah, thanks for joining, even though it is 2 a.m. That's awesome. And we're gonna try to use it. I say try because I've never actually used it. So I've imported it. I don't think that you have to do this extern anymore. This extern crate BitVec. We don't want SerDes support. No, this is fine. We'll just try this. So now let's give this a try. So basically, what we have here, let's go ahead and open up the advent of code. This was basically the challenge right here. It's pretty straightforward. Basically, each row you add up, or each column you add up. Basically, if it's 1 or closer to 1, then man, is about the only word that I say proficiently in the English language. Anyways, if 1 showed up in this column more than 0, so if you take their average, if it's greater than half, then you say this column is a 1. And if 0 showed up more, you say this column is a 0. And you build an array of bits based off of that. And then you convert that bit array into a number, which is what I couldn't do because I didn't have bits. I just had integers. And so this is what we're using this BitVec for. not only is it a bit vector, hopefully it just gives me a way to manipulate bits, because I never did have one. All I had was integers, which is what I stored. But as we found out, integers sucked. That was quite horrendous. So we can really quickly go over that code. This is the code. It's not my proudest moment. I'm just learning Rust. I touched Rust like 2 years ago. Absolutely loved it, but I've never really done a whole lot in it. And now I'm making a concerted effort to actually do it. And this code is rough, so go ahead and hate me for it. That's acceptable. But this is a tuple, and it's a tuple of integers. And basically, this is our input that we were given. And so this tuple represents a single integer for each input, so for each column. And basically what my approach to this is that we will just iterate over this list, and we will add up each one, and then we'll divide by the total number in the list, which happens to be 1,000. And so that's what we do. Each time we break the tuple apart, we then set the tuple to that byte line. We just add it. And so we have, at the very end, a tuple with each and every single one. We can then divide by 1,000 to round it, and that's what this function does. It's a pretty simple little application. Its code isn't great. I get it. I can't hate what you can't read or write. So basically you're saying I can't hate English because I can't read or write it. No, I'm just joking. I don't read or write very well, though. All right. All right. So yes, I can barely read or write it. So basically this tuple comes out, we parse it into this. So we're rounding it, and the rounding output, well, we're just eating it right now. We don't actually have the output, but the output would be something like this, where we have a 1 or a 0 in each column. And this would give our omega value. But again, we ran into a part where we don't have any way to deal with bits or bytes. So that's where this bitvec comes into. So this allows us to set an index to true or false. So I think what we need to do is update this to return a bool instead of so true or false. And this would be return true and return false. So basically this just takes, whatever we did and is a true or false. And then this way we can actually just take this bitvec. We're going to make one. So let's make one right now. I think this is how many, and so we only need 1,000. We don't need this many. We'll update this. I'm copying and pasting my it's the one thing that I'm truly good at is copy and paste. All right, so we're gonna make this right here. This is us breaking apart the tuple. If you're unfamiliar with what this is doing, basically you can assign variables to each of the values in the tuple. It's a tuple of int 32s, and we're just saying A equals the first one, B equals the second one, C equals, and so you can reference them as variables. That's all I'm doing right there. Anyways. So we're going to make this bit vector here. Bitvec from element. It doesn't know what this is. Oh, I'm not using it. I just did an extern create. So I think we need to do a use bitvec star. I'm pretty sure that's what we're going to do. We're just importing all of bitvector. I know, bad practice. All right. So now it knows what a bitvec is, so this is good. From element max primes, this is going to be 1,000 because we can hard code it here. I know, not best practice, but it's actually not 1,000, it's 16, right? Our vector is going to be this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12. It's going to be 12, so just 12. Going to be a vector of 12. And then this, what is this bit true? I don't know what this, let's go back to the documentation. Why do they pass in true here? Assume all numbers are prime to begin, and then we can cross. Okay, so this is like the default value. So we're going to say the default value is false. It doesn't really matter. We're going to set each one. I don't know. That is what we're going to do there. All right, so now we have this unallocated bit vector. Well, I guess it's allocated since it's Rust. And let's see. Now what we're going to do is assign each one of them. So what they say here is it's just bv.set. Perfect. So here we can do bvo. So O. I think we need to delete this because this is like making an array, and we don't need to make an array. So let's delete this. We're going to do bv dot set. Yeah, just set. And this is going to take the integer, and the integer is going to be 0 for this one, and the value is going to be this, and colon, right? Is that right? Probably not. Let's see. That seems to think it. So yeah, for the very first one, it's the value of A. All right. So I think we can just copy and paste this. That's what I'm going to do. Oh, not do that. I still don't have a good solution for undoing yet on this keyboard. I need to actually update the keyboard. So one of these times, this stream is going to be about updating this keyboard to be effective. But that is not this day. I sound like Aragorn. This is dumb. I forget Alt. That's Alt. I got Alt. Okay, well, that was a waste of time because I messed it up. Just do this. And save that. Okay, so now we have a bit vector with all of our bits. Rust is almost readable. Well, you know what? I wouldn't blame the code that I'm putting out right now because I feel like there has to be a better way of doing this in Rust. I'm just not the person to tell you what that way is. So yeah, not the person to tell you. Okay, so we have this bit vector, and now we need to make a number out of it. We need to actually make an integer out of it. I wonder if the documents have, the documentation has how to do that or not. Let's see. See, I'm not even sure this solves our problem, this bit vector. I need like a bit vector to int. And it won't convert. Yeah, see, like, I need this U32 from bytes. But it's one in U8s. And this just has bits. Let's see what functions the bit vector have. BV dot. All right, is empty iter length. Two bytes. Wait. 2 bytes. Okay, what does this have? What does this return? Take me to this. A vector of U8s. Okay, if we can go 2 bytes, we can take the bytes to an integer. So let's do let bytes equal, yep. Sorry, equals in the wrong place on this keyboard. bytes. All right. This would be our bytes, and then we can do from bytes on this. Right? Right? No, because this is expecting a slice of 4 bytes. Okay, so to do this one then, I need to do this into a slice. How do I do that? A vector to an array, yes? I think you can do this with a fancy select. So Rust array, no, a Rust vec select 4. So I think you can do like a 0.4. Let's just try it. I think you can do it. I think you can do it. So what we're going to do is bytes, and we're going to select like this 0.4. Okay, they found a slice of. Oh wait. Three. Sorry. All right, mismatch type. Expected array U8 of length 4. Found slice of U8. So this isn't quite giving us what we wanted because the from bytes is expecting a length. This length of 4. And for some reason, this isn't giving that. It's just a slice of you. Okay. We're on to something. I don't care about your guarantees. I mean, I can just longhand this. Okay. I mean, like, let's just do that. We'll do let byte array is going to equal bytes at bytes at 0, bytes at 1. We'll just copy and paste this since I'm pretty slow on this keyboard and we don't have all night. And 3. All right. And then we can just use this. This byte array is now this U8 of 4, length 4. This is what they're expecting in here. Let's run this. Are bool vectors not illegal? A vector of bools? No, I don't think that's illegal. Which is basically what a bit vector is. I thought a bit vector was going to give us something a little bit better, which I guess it does because it has this 2 bytes function, which basically just adds them up. But we'll see. We'll see if this actually works. I doubt it does. I don't have my faith in my Rust. All right, so day 3. Oh, okay. So this makes sense. I actually had thought about this last time we were doing it. This is going to only give us, let's see, there's a set of 4 here, and a set of 4 here, and another set of 4. So it doesn't have this last one. So this last byte is always 0. Wait. It would be the first byte, though, because I don't know how it reads it in, whether it's big Indian or little Indian. Like, I'm going to guess over here is 0. Well, that's... Wait. This is big Indian. Which way is big Indian? I don't remember. All right, so the native, his biggest N goes first to the lowest. Okay, so backwards, like I said. This would be at the beginning. Okay, I think. We'll see. I could just be super duper wrong. Usually am. All right, this is at 49. Wait, it says the same thing. So it says there's only length of 2. Oh. The length is 2, not the index. Oh, and the index is 2. It's only making 2 out of this? Oh, it's of a U8. Of course it's only making 2. I'm a dum-dum. All right. We'll just delete that. Nobody saw that, right? All right, let's go back to this. Sweet. So it ran. It didn't print. Did I not put a print line in there? It did not print out what this is. Okay, now we just need to print that. Do I remember how to print without looking? That's next task. Print without looking. Here we go. This is going to be print line. This right here. We're going to make this funky thing. It looks like this. Yeah, that's what we need. All right, and then once we have that, we can just put, that should be the number, the magic number. All right, let's see. 32,700. That looks suspicious to me, but I don't really know off the top of my head. All right, I think we have to multiply it by the other one. Choose binary, calculate the gamma rate and epsilon rate, and then multiply them together. Right, so we can't even see if that is correct. We have to also calculate the other one, which really we just need to invert this. And yeah, so basically this is false, and this is true. And other. Okay. Yeah. I feel like, okay, so if I knew Rust a little bit better, there would be just an easy way to flip all these. So we could just use a mask on it and flip all of them. But I don't know how to do bit math on this, honestly. That would be the easy way to do it because we already have our bit array here. We just need to flip every bit. In just about every other language that I know how to write, except Go. I really don't know that I've ever done that in Go. In C++, this would be an easy chore. I don't know what I'm doing. So we're going to just do this. Oh, man, I don't want to do this all over again. This was a lot of tedium. Oh, well, I guess we're just doing this all over again. Okay. Well, let's copy and paste. We'll do it a little bit lower here. This library didn't seem too well documented. Like I was struggling to find, like, I want to do bitwise operations on this. And like it's all around having a bit vector. Yeah, like this is the documentation. Okay. But I want to just apply a mask, right? I just want to flip them all. Okay, so this is setting them all. Wait. So, yeah, that's just a set all. Oh, flipped all bits. Oh, wait. We can just call a function negate. There we go. I was about to do something stupid. So instead of doing all this, all we have to do here, instead of doing this, all we have to do is let the flipped. We're gonna. I forget what it's called. What did they call it? Let's see. There was the gamma and epsilon. So it's the epsilon. So let eps is going to equal. This is the epsilon bits is going to equal the BV dot, what was it? Invalidate? Not invalidate. Negate. And then we can do the follow-up for these. We can make it a byte array, and we can get the actual value. Byte array eps is going to be these here. Oh, wait. This is not, let's do 2 bytes. Oh, I can't call 2 bytes on this? Okay. So then we just do let's eps bytes equals over on the other hand now, bv dot 2 bytes. Okay. And now we can use this here. Yep, here. All right, everything happy? Not this. All right, this is then used here. All right, now we should be able to print both of these numbers out. This is the epsilon value. So let's copy this and print this out. And then we need to multiply them. So let's go ahead and just print that out as well. And we can see if it's the right answer. I kind of feel like it shouldn't be, but I'm not even sure what. Yeah. There we go. Those numbers are oddly close to each other. That gives me a little. So they either did it that way, specifically to make them oddly close to each other to throw you off, or I still feel like this cannot possibly be the right answer. We'll try. It's not the right answer. Yeah, it's too high. Okay. Where did we go wrong? Well, this is a lot of garbage code. You know what? Let's validate what we're doing is actually working. So let's make a bit array of a known value and then serialize it. First, I did this with the big Indian, which maybe these numbers should be over here. No, because we don't have enough values. They didn't give me. They gave me, oh, that's input for day 1. Where's day 2? Input for day 2 is there, but I need day 3. Where's input for day 3? Okay, well, they gave me these numbers. And so there is only 12, which isn't, it's only half. But which half did they give me? I guess my understanding was that they gave me the second or third half. 1 second, my monitor died. Let me try to restart it. You guys can actually see what's on my monitor. I can't. I can do this now. Neither of us can see what my monitor is doing. There, it's back. It's something that happens because of my dock. It doesn't like Linux. All right. Restarting the monitor seems to fix things, though. All right. So I don't know if these are big or little Indian, which I feel like is... Did they state which one it is? Considering the first bit of each number, there are 5 bits and 7 ones, since this is the most common one. Okay, blah, blah, blah. So the gamma rate is the binary number 0. Oh, okay, so they give us the hint here. This decimal is 22 in decimal. All right, so this is probably our hint here as to which way it's encoded. For this to be 22, you know, this is 1. Okay, so 2, 4, 8, 16. Which is the way that I thought it was going. Oh. Here's my mistake. Rookie mistake. Why am I doing a U32? If it's a U16, why not just do a U16? Right? Why did this change its signature to any array? What? Okay. You know what? I don't know. Why is U8, U32 more restrictive than U16? That doesn't make any sense to me. This can't possibly compile. 1 second. I need to see if this compiles. Okay. At least it doesn't compile, which... Wait. Though it kind of did. It got past where I would have expected to. Okay, the multiply overflow is the only thing that stopped this from working, but these are the same numbers that we got. 32,768, 32,768, 32,752, 32. Yeah, so I did the original math correct with the big and little Indian, and oops. And this makes sense why it would have gotten an overflow. Because we're multiplying 2 base 16 numbers with a large number. Okay. But we got the same number. Let's take their example and do it. So right here we know that this is 22. Let's do this. So we have a 16-bit array. Let's just define this. we're going to make a new one. So let mut bv test is going to equal our bitvec, equals on the wrong side of the keyboard now, bitvec from element from bytes. Ooh, can we just do from bytes? No. I need to do from element, and this is going to be our size. So our size is going to be 16. No, it's going to be 12. It's going to be 12, and we're going to set it to false. So we're just going to have all zeros at the very beginning, and that's going to make it pretty easy because then we just have to set the few zeros that we want. So we do bv dot, bv underscore test set, and we're setting the second index to true. We are going to do this for the fourth and fifth index too, right? I believe so. One second, we'll check in just a second. I think that's what they set. Let's check. So index 0, 1, 2, 1 and 2 and 4. 1 and 2 and 4. Sorry, I was completely off. 1 and 3 and 4. 1 and 3 and 4, right? I did that again. 1, 2 and 4. 0, 1, 2, 3, 4. Yeah, 1, 2, and 4. 1, 2. Wow, I'm really off tonight. 1, 2, and 4. There we go. So this should give us a number of 22. And that would be replicating what they gave us as an example. If it doesn't equal 22, we need to figure out how to make it equal to 22. And then we'll be doing the exact same thing for their numbers as we were doing for our numbers. And then all we have to do here to keep from the overflow is to cast these to 32s. And we'll be fine. Okay, so let's do this. So first we need to do 2 bytes on it, and then we can do the byte array. Let's just do this. So we need test bits. We don't need to call negate on this, so we're just going to delete this. We're going to do test bits, and we're going to do this. 2 bytes, and then our answer is just this right here. And we'll just print out the test. And this should be 22 if we've done everything correctly. So that will be the first thing that prints out. All right. Oh, I am not that good at copy and pasting. Oh, I've got to make it an array. Okay. Yeah, I'm failing at copy and paste too. You guys cannot learn anything from me. I'm not to be trusted. So this is going to be test bytes. Please, somebody speak up and tell me how there's a much better way of doing this than what I'm doing. If you know, I would love to know. Okay, so We absolutely did not get anywhere near their 22. So let's reverse our Indianness. I don't know how to pronounce that. All right. So instead of doing this, we'll start at the other end. Why are we doing 12? That's what we did up here, but that's not... We should be doing 16. All right, so we should start at 16 is 1. So our first one is 16 is the first index. Our second index, but we wanted the second index, so that would be 15, 14, and then skipping 1 would be 12. All right, this should be 22, right? It's 11. It's 11. We're close. We're on the right track. It's wrong, but it's a better number than this. That's a better number. So, you know what I was just thinking is this is from BE. So let's undo this. Let's undo this. Because that's more readable. And instead of BE, there should be a from sanity. Any. I don't know what any. Shouldn't it be like Little Indian? Ellie? Should be Ellie, right? It's wrong. Now, it's either wrong because I set the wrong indexes, which I don't think so. Yeah, I don't think so. Now I'm getting all confused in my head. This is really the end of the index. So in a 16-bit number here, we need 1, 2, 3, 4, 5. All right. And then we need a bunch of zeros before that. And then this should be the 15th index, the 14th index. All right, we were on the right track originally. Why did I undo that? This should be 14, 14, 12, and 11. And this should be BE. And that makes the entire world make sense. Probably. 26. I feel like I'm so close. What did I miss? What did I miss? I need to write this out. 1 second. All right. Our 16-bit number is this right here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And our indexes run like this. 0, 1, 2, 3, 4, 5, 6. That's not a 6. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You know what I'm going to do? I'm just going to delete the leading one just so that they all line up nicely. We can remember that these are in the teens. Okay. So these are our indexes. So we want this one to be 0, which that's true. And then we're setting this one to 1, this one to 1, and this one to 1. That's perfect. We did it exactly how I designed it to be done. Oh, except they're doing Little Indian. They're doing it the other way around. So that wouldn't make sense because what is... 1 second. Now I'm just confusing myself. Where did I go wrong? Let's make these comments. We can leave these here. This is a good reference. Good reference material. Oh, there's Ellie, not any. I said Ellie sounded more right. But if we do Ellie, we need to do this the other way around, right? This shouldn't work. Yeah, I wouldn't expect Ellie to work that way. I would expect Ellie to be, what is this? 1, 2, and 4. That's what I would expect Ellie to be, right? But if this works, I don't know why the other one is 122. So not quite right. Not quite right. Still not encoding this quite. Oh wait, I said 1, 2, and 3. I meant 1, 2, and 4. Like that. This is still not going to be correct. Yeah. What am I missing? I need to go back and read up on Little Indian and Big Indian is what I need to do. I don't know what this any is. I feel like it's trying to determine which one it is, but who knows? It looks to do Little Indian when you do any. Okay, so what can we do? I mean, we could just guess around to get it to be 22, but I feel like that's not going to help our learning, and our learning here is how we're learning how in bits to write. Ooh. Wait. I think we can do this, can't we? Yes, I think we can. So when we were looking at this library, the bitvec had negate, but it also had from, didn't it? From function, from bytes. Okay, so we should be able to build a bit vector from bytes, and then we should be able to print that one out to see what it looks like, right? Let's try that. Let's do that right here. So we're going to do this, but instead of doing it like that, from bytes. And in here, not that at all. In here, we can give it a slice of bytes. Oh. Turns a byte vector into a bit vector. Each byte becomes 8 bits, right? That makes sense. With the most significant bits of each byte coming first, each bit comes true. Okay, so what we need is a... I'm not even sure if this will work. Can I make a... I don't even know how to declare one there. Oops. So maybe what we need to do here is let 22 equal to 22, but we don't want I32. We want to actually designate this as a U8, right? I think so. And then this U8. we actually want this to be a array of. Oh, has Visual Studio gotten a little more annoying with popping stuff up? Like, I don't want it to pop stuff up. That's annoying. It's very annoying to me. I don't want it to pop stuff up. Is that how I make a slice of... I want to make a is that not cannot assign to this expression. Pattern requires 2 elements, but array has 1. Expected 1 element. Okay, well, I just want to make an array. Value of type. Okay, how do I make an array? I just want like a static array. Oh, it's a semicolon. Of course it is. Okay. I was very close. I did comma. I'm sorry. I did a comma, not a semicolon. I should have known. Should have known. They just want a reference. Wait. That would be dereferencing. Cannot be dereferenced. Okay. Can I just make this a reference? That cool? Nope. Consider borrowing here. Uh-oh. I didn't want to get into borrowing. I don't really want to borrow this. How do I borrow? Can I just do that? Is this legal? I don't know what I just did. I slapped these on here and that made this happy. I'm not entirely sure what I did though. But I made it happy. So we're going to stick with that for now. We're going to need to figure out what that was. But okay, so we have this. What were we going to do with it? Now we need to just have it print out its bits, right? So how do we print out its bits? Let's look. Blocks. This might be what we need. I was hoping we can just print it. So this allows you to do the union and intersect. It allows you to do all the stuff that you would do with a normal bit thing. Okay, so that's good. I wish they would just do like XOR. That would make more sense than difference. All right. So we can just iterate over it. I don't want bytes. I just want... I just want to print it. I just want to see what it looks like. Okay, I'm just going to try to print it and see what it... Yeah, this is pretty much like C++ and the compiler hates you. C++, the compiler doesn't hate you. It just likes to let surprises in. This one, it actually actively hates you and thinks you're stupid. And I am stupid. Actually, I think that this is just a message. I don't... All right, so what were we doing here? Okay, we just need to print this out. I'm just going to try and print the structure and see what how it prints out. hopefully, yeah, it can't be printed because it doesn't support STD format. The trait. Okay, so let's try one of these. I don't quite understand this, but I do know that these let you print some other stuff out, so that seems to be working. So let's try that. I don't know how I accidentally... All right. Gosh dang it, that is the exact... Okay. So that's how it printed out. That's what we would expect. Like, that is what we expected from... Ooh, you know what we need to do? Okay, this is good. This is really, really good because we need to print this out and see what it looks like, how it's reading it in. Okay, this is progress. Even though it doesn't feel like progress, but it is. Let's print this out. Yep, doesn't feel like progress, but I feel like it feels like progress. And then this is 20, I can't spell, 20, 2. All right, progress is being made. Let's see what this does. Okay. Why the, 1 second, did I do something wrong here? Oh, I did do something wrong. I wanted the bit array. Wait, where's the bit array? Oh, this is the bit array. Yeah, I'm my bad. All right. Now we have some progress. Okay, so this is currently backwards. That's fine. That's fine. We can fix this because yeah, okay. But this is what we did, where we did so again, we're trying to make this structure. So this would be the 15th spot. So we want 14 and 13 and 11. 14, 13, and 11. So we'll say 14, 13, 13, and 11, right? Right? Let's go back and see this. So we want one back. So if this is 15, this would be 14, 13, and 11. Okay. Let's save this and let's run this. Okay, we have this in our 22, but it comes out at 5,000. So now let's play with our Indianness. We need big Indian, right? That's what we're going to do now. Big Indian. Big Indian. We have to... Isn't that what we did? I feel like it's making fun of us at this point. I feel like that's what we did, and we didn't get 22. It's now absolutely making fun of us because we got 22. At least this makes sense. All right, so we know this makes 22, and this works. Now, why does this not work? I mean, we could flip these two around, but my fear is that this 2 bytes... I mean, let's just flip them around. 1 second, because this is the first index. Oh, maybe that's what... No. That would be weird. Flipping these around shouldn't work that way. So we call 2 bytes. And our index, the smallest to littlest, should go the largest numbers to the left, littlest numbers to the right. That's what we're doing. And we have 16 of them. So that means these here, when we set them, go from smallest. Oh, guys. Oh. We're dumb. Nobody told me that these were never indexed. Where were you guys when I needed you most? Where were you guys? I told you that it looked a little suspicious that when we were first running, that these numbers were so close to each other when flipped, which would account for one number being different. Only one. And that was only the first number. Okay. Was that our only problem? That was our only problem. It was still good. We understand this probably a little bit better. Let's run this and see what it looks like. Oh, we're still gonna get a panic, so let's fix that. This panic here, we need to do. Let's see. I think we can just do U32. Can't we just wrap this in a U32, or is this like? Am I pulling this from a different language? Dang it. I just want the 1. No, I think I can do that here. I think I can do that here. Nope. Is just from acceptable? Can I do that? Maybe I can do that. Okay. That should keep us from hitting a panic. But it printed out 0. Maybe it printed this out. No, I think it printed out 0. Was one of the numbers 0? Okay, now we need to label these a little bit better. First, let's stop printing out our tests. Those are useless. I'm way too happy with the clicking button. No more tests are needed. Thank you for your help. You were valuable research, but you will be commented out now. I'll leave those. Okay, so let's see. They're saying these numbers are 0. We got 0, 0, and 0. I think that's what's happening. So something's very wrong. Oh, the negating is 0. And then if you multiply by 0, of course, the final answer is 0. So we have 65,520. And then we negate it and we get 0. That's wrong. Okay, that's something we can work with, though. Let's see. So for our negate, where did that happen? It's bits negate. Before equals this, after equals that. That looks like negating. Oh, I did a bad thing here. Check this out. If we go here, go to definition, it doesn't return anything. I thought that because it was mutable self. Okay, it's just mutating itself, not returning something. No, go back is what I wanted. Go back. All right, so we just do this, and we don't need epsilon bits. We just are negating our current bits. And so that means we really should use this. Oh, wait, that's what we were using. Uh-oh. Maybe that's why. Edit, undo. Let's see, because we really need to be using this here. Because I think this negate actually consumes itself, but I could be wrong. No method, 2 bytes, found and unit type. Yeah, it doesn't like this unit because it's just nothing. It's weird that it allowed me to do that. Okay. But why is this not working then? Let's run it. Maybe just setting it to something was causing it to act strangely. Yeah, negating is still making it 0. Which that would seem to imply that all of these were set to 1. So let's actually print that out. Let's print this this array out because that's what it would imply to me. Print, you know, if they were all on, then negating it would be all off, which would make sense. Let's see, print my tup. We need the cursory thingamajig. I don't know what to call that. The curly brace nightmare. You don't like that. Okay, so I guess we do this little thingamajig. Yeah. Not sure why. That's just what we do. So these are not the numbers I expected. There's only 1,000, so it should be less than 1,000 is the count. It can't be more than 1,000. How is it more than 1,000? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12. Okay, well, this is that we've done something wrong. Because there's only 1,000 in the file, right? Right, there's 1,000. And we should be counting and adding 1 each time there's a 1. So there's something else wrong here in this logic. So we read each line from the line buffer, then we unwrap the line. If that line is an actual line, we then let each byte as a byte. Maybe this is the thing that's going bad. Let's print this. Print line, curly braces. I'm getting the hang of it. The curly brace. Byte line. What do you not like about this? Must be missing a string literal. I guess a U8 is not a string literal. Does this fix it? Nope. Nope. Okay, so can you just not print out... Well, we can print out the line. That we can do. Oh, we have these weird curly braces. I got happy with the curly braces. Now let's try the byte line. Okay, so now we need the curly brace, or the question mark. All right, my bad. I don't know. Rust still looks a little weird, so I don't notice when something is weird looking. All right, so this is what I'm kind of worried about, is that we're doing this translation wrong. We can look at the last line of this. This is what it printed out. 48, 49, 48, 49, 49. Okay. But are we actually reading that correctly? Because that last line, I mean, it's 48 and 49, which is ones and zeros. Are we actually translating these to ones and zeros? So let's just print the tuple afterwards. Because we should just be adding these together. So you're just adding one if it's one, and you're adding. But what I think is happening is, and I can actually guarantee what's happening, is we're actually adding 48 or 49 because this is the UTF encoding of, if you looked at the ANSI diagram, 49 is for 1 and 48 is for 0. That's what's happening here. Okay, so what we need to do then is actually just take this through a translation. I was hoping this would read it properly because I was taking the lines and I was hoping as bytes would actually translate it to the right thing. But it makes sense why it's doing it the way it's doing. We just are going to have to translate it. So instead of doing this, we're going to need to make a function to translate it. And this round other is garbage because we have negate. So we're going to do a function that says is 1, or no, that's dumb. Translate to ones and zeros. That's really long, and it's going to take in a U8. Let's see, what are we going to call this U8? Input, because I come up with only purely original names. And that is going to give us a U8. We could do, I'll do an I32 since that's what we're already using. This is garbage. Garbage code, don't ever do this. If, this is even worse. If input input equals 38 or 48. Is it 48? I think it's 48. Yeah, 48. If input equals 48, we're going to return 0. Otherwise, we will return a 1. And of course, we need 2 of those. If that doesn't make you a little sad, I'm sure Rust has a way to do this. I just don't know it. I just don't know it. It's almost gonna work for all of them. And then we just need to fix these 2 down here. All right. Still need to get used to the arrow keys on this keyboard. They're kind of all screwed up. All right, so, and now we don't have to do this from because it's going to already convert it to a I32. Okay. I could have just left the multi-line. All right. Let's see how that looks. That actually is probably right-ish. Right-ish. All right, these numbers look reasonable. 522 times 360. So this would be a 1. This would be a 1. This would be a 0. This would be a 1. 1, 0, 1, 1, 1, 1, 0, 0. And vice versa. So this number is actually probably correct. I'm actually confident enough we're going to actually just go ahead and apply it. And then count our lessons learned. It's probably wrong still. Who knows? Is that the right number? Did I copy the right number? Yeah. 84. Too high. All right. So the only thing I can say is that possibly Little Indianness is getting us again. Are we sure that we actually translated the number correctly? I'm not entirely sure. But it does look like we are counting correctly now, so we can get past this line. Beautiful. Let's actually look at that really quickly. All right. Perfect. This looks good, though. Looks like what we want. Now, as far as it gets down here, am I inverting this? You know, I'm kind of thinking that's the problem, is that I'm putting these incorrectly. And this should be 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Could that be it? Could that be all? This number is just larger though, so I don't think that was the right answer. Let's see. I think it's larger. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 digits. I think that's larger than 1, 2, 3, 4, 5, 6, 7, 8, 9. It was still 9 digits, but it's still larger. So that's not the right answer, which I'm happy. I'm happy that's not the right answer. I think we are right in our original ordering. Like this. Did you get here too late? Probably. We are doing some coding right now. I am learning Rust, so this is not a great time to learn to code. I mean, unless you're trying to learn Rust and already know coding. This is some pretty crappy code that I've written. I'm not going to lie. This is nothing I'm proud of. This is nothing I would show off at an interview. This is me learning Rust, which I've had actually some struggles with. I touched Rust like 2 years ago, really liked it, but I never really got the rough edges. Now that's what we're doing right now. I'm doing a little bit of Advent of Code, which is fun, but they're asking me to do some bit operations, and I'm struggling. I'm not gonna lie. I'm probably close to calling it quits for the day. I've already been working at this for an hour and a half. We've actually made some pretty good progress. I'll leave the stream up, but streams aren't nearly as fun. You already know Rust? Okay, you should have been here sooner because this is embarrassing. If you know Rust, please don't think badly of me because this is not code I'm proud of. Here we go. All right, the challenge is basically they gave me this input. And what I had to do is each one of these columns, add all of them up and see if there was more ones or zeros. If there's more ones, the value for the first column is 1. If there's more zeros, the first value of the first column is 0. And do that for each column, and then build a number based off of those bit values that I got. Now, the first hurdle that I came across was that Rust doesn't support bits really in the standard library. There is no bit value. I mean, there's a bool, obviously, but there's nothing to do with that. So there's this bitvect library that I'm trying that. So that was last Thursday. So today on Tuesday, I tried to use this bit vector. There's this bitvec library that I've been trying to use. And I've used it to pretty good success, to be honest. So we did a little experimenting with, like, here's my 16-bit integer, and I'm doing 2 bits, and I expected it to be 22, and it printed out 22. So that's what it was here. And so, like, yeah, this is 22, a 16-bit 22 integer. So I got that working. Now the answer is I'm not getting the right answer. And why? Now, I just realized something. This is actually a 12-bit number that they're giving me, which is interesting because I only have a 16-bit in here, which means I think I'm going to have to pad this with zeros. This is the answer. Thank you for joining. You have given me the answer. I have to pad this with zeros. We need to make this a 12-bit or a 16-bit because that's what Rust is expecting. I love rubber ducking with people. Thanks for joining. I have to give this a 16 because it's actually a 16-bit integer. And the thing is, I need to leave the first ones empty. So 16 divided by 12, or divided by subtract 12, that means that we have 4 extra. So our first one should be not on 0, but on the fourth index. So this should be 3, 4, 5, 6, 7, 8, 9, 10, 11. I should have started from the end and gone back because then I would have known success instead of having to guess because I screwed this up. Like I said, I should have started from the end. Stop popping stuff up on me. I hate Visual Studio Code. I need to get better with I have a new keyboard that's split and its arrow keys are funky and I'm not familiar with them. So 13, but I need to get better with them because this stuff is better with them. 12, 11, let's go over here. This will be 10. So I did the math wrong. 9, 8, 7. I immediately thought 4, but then I was like, oh, but I'm indexing it from 0, but I should have stuck with 4. Okay, anyways. This should work, right? I think this will work. Let's see if our number gets smaller. This number was too big. Our number should get smaller. That is not smaller. That is 9. It is smaller. I don't know that that's... I mean, I don't know what the answer is, so I guess that could be the smaller they're looking for. 1, 2, 3, 4, 5, 6, 7, 8, 9. It is smaller, so I guess we'll submit it. And see if that's the right... I feel like it's wrong. It's still too high. Okay, so that's still too high. I thought it was probably still wrong. So now my question is did I pad this the wrong way? Did I pad this the wrong way? So if we go to our input, I basically put zeros here, right? Pad it out to a 16-bit. That's right. I didn't do it wrong. Let me make sure. This was with Big Endian. Am I doing it with Big Endian? I am doing it with Big Endian. Okay, so yes, I'm right. I'm doing it with Big Endian, so padding to the front should be the larger values, which we don't have. So I skipped them. So, past Patassa. I'm sorry, I don't know how to pronounce your name. All right, so let's. I can step over what we did. First, we just basically read every single line in. That's what this is doing, and then we stored it in a tuple, and we just actually added up how many zeros there were. So this translated in ones and zeros, and we just added them to it. And so in the end, we get this tuple that looks like this with basically how many ones were found in the whole list. And if you, this is ANSI 1 and this is ANSI 0. And so this gives us that tuple. And then we're translating this tuple to ones and zeros. So basically what I do for this is I divide this by 1000. And if it's greater than 0.5, if it's 0.5 or greater, it's a 1. If it's because 1 was found more often. I'm just using some simple math for that. And I'm just building that tuple. I'm using that tuple to then create this bit vector, which then I can create a number from. That was at least the idea. I don't know that this is working though. I mean, our tests work. Our test stuff made sense. And this is why we did these numbers, and this is why I padded this way. This is 22 like we expected it to be, which is our Big Endian, which... Now I could change this from Big Endian to Little Endian, but that would just be wrong. Unless, because their number's not in Little Endian, it's in Big Endian. What's your thoughts on this? I'm a little stumped as far as where to go from here. Let's make this a print line while we're at it. You should definitely join Thursday a little bit earlier because you can probably give me some pointers because this is probably really, really bad. You're probably like seeing like 20 things I did wrong and it's a little overwhelming for you. And for that, I apologize. Let's see, I'm initializing with 0, false. We have 16 bits. We're breaking that into 2 8-bytes segments. I would say, you know, we're out of order, but we actually tested the order already, and that's true. What am I missing? What am I missing? So it's Big Endian. Oh, my camera died. I was afraid of that. It's battery. Oh well, no camera for the rest of this. Okay, so actually I can make that a little bit better. So now you guys can just see. Oh, there we go. Okay. So the Endian is Big Endian, per their statements here. They said that this number was this, and this was 22. So that would be Big Endian. I spent 10 minutes making sure that that was Big Endian. Sorry, it's not often that I deal with bytes. And unfortunately, at this point, we're not solving their problem. I've solved the problem. It's just I'm screwing something up with the bytes, and I don't deal with them very often anymore. So anyways, this is Big Endian, where the higher numbers are more to the left. Now, there isn't a 12-bit number in Rust. They gave me a 12-bit number. There's 12. So I'm putting this into a 16-bit number, which is why I'm padding the first ones, because those would be the larger ones that are outside the domain of their number. And this is right per my tests, just to validate. Because the 0, 1, 2, and 3, the first 4 bytes, would be the largest bytes. Right? Or am I completely insane here? I might be completely insane. It's been 6 years since I've done much with bytes, other than like XORing. Okay, I'd probably do more than that, but I don't do it in Rust. I didn't calculate a value in bits? What? What? You calculate 2 values and multiply them together, right? Right. So the end goal is we do this first one, which is if there's more ones than zeros, it's a 1, and if there's more zeros than ones, it's a 0. And then you invert that. So that's the gamma rate. That's the decimal number in gamma. And then the inverse is the epsilon rate. So basically you invert the array, which it's an easy calculation because we just did negate on the byte array. And that gives us, I mean, this is just bitwise operations on decimal. So we don't have to redo this. And then we multiply those two things together. That is correct for the final answer. That's what we're doing here. This is, I have no idea why the variable is called that. That is the gamma. I think that's the O number. And then the epsilon is the ep. So to get the epsilon, we just negated the byte value. We got the bytes from that and got the from bytes on that. So we build this 1 byte array and we get the gamma. Yeah, it's misspelled. So this is the first value we calculate. This is the second value that we calculate. But this second value should just be a negation of this byte array. Oh, you've done it. We negated the larger numbers that weren't there, the 0, 1, 2, 3, and 4. So on this epsilon, we negated some really big numbers that didn't exist. So we cannot do this. This hurts my soul. I don't know what to do. Okay, so I now know the problem. Good point, because we're negating these 4 bits. This works for the beta, the gamma, but it doesn't work for the epsilon because we're negating 4 extra values. Do we build this? Okay, can we clone this? Do we build this again just with the right size? So I guess what we actually have to do is just build this array again. We can't just call negate, which is really dumb. Because we need to pad this, but we also need to pad this one's array as well. So we're just going to actually have to build it out again. I think that's the answer. Dang it. Or like manually negate it, like go through and write a function to take each byte from the byte array and negate. We could do that. Should we do that? Man, that makes me sad. Okay, well, I think we know what needs to be done now. Let's do it. It is late for me. I need to go to bed, but I actually really want to do this and get this kind of behind me. So, let's just do our own negate. We have to skip the first 4. We don't want to negate those. And then we want to negate everything else. All right, so we can't call this function, but what we can do is make a function called our custom negate. And our custom negate is just going to ignore the first 4 values and negate everything else. Okay, so custom negate will take a byte array, a byte vector. And we're going to take one of these bad boys. If I get into borrowing here, I'm going to hurt myself. I'm going to take a byte vector, and it's going to return a byte vector. Yes. I'm just going to make a new one, I think. Oh, that's probably going to get into borrowing rules there. Maybe we don't. We just negate it in place. That's what we're going to do. We're just going to negate it in place. I probably have to tell it to pass a reference to this. Do I have to, like, say make that a reference? Maybe. We'll see. We'll see. All right. So we're going to take this, and we're basically going to say we're going to do a for loop on this. Can we just do it in place like that? I don't know if it implements an iterator. I think it does. So we're going to try. We're going to say for byte or bit. How do we do this? It's for in BV, right? Right? I don't know. There's like a 2 iterator. Do I have to do the 2 iterator? Let's see. Yeah, 4 line. Oh, I don't have to do the colon. Never mind. Can I just do this because it implements the iterator? Maybe I can. Maybe I can. Maybe I can. Oh, that's beautiful. All right. There's no borrow problems if there are no references. Well, let's delete this reference. Whew. All right. I need to learn how to borrow, though, so, like, I'm not going to be able to make that excuse all the time. I should do some references at some point just to borrow, because I feel like Rust won't be painful once you borrow properly. Like, once you understand how to borrow, and it shouldn't be that big of a deal. Unless if you're telling me that, like, borrowing is always a pain, and then that's, like, that sucks. But we'll find out. All right, so 4-bit in bool. Okay, so bit is a bool. So can we just do if bit? Oh, this is going to be a problem. I was going to do if bit then bv.set, but I need to know the integer here, so if bit, then we'll do not bit. Actually, we can just do not bit, right? That should work. But what we need to do here is not if bit, but can we do like the iterator here? Is I the in a for loop in Go, you can actually get the index that you're currently at. Can you do that in Rust in a for loop? I've never done that. Rust for loop get index. For, oh, okay, so you just make it a tuple. Okay, okay. I can do that. For ibit. Ibit. Okay, so someday it will click and you just have to play with the language long enough. Right, right. Okay, that's what I am assuming, that I just have to do it enough and feel the pain, and then it should just be no problem. Wait. I don't understand. Expected type bool. Mismatched types. Use expected type bool, but found tuple. Well, this is what it said to do. It said for ix in oh, and this is what you're telling me. Okay, okay, I need to do this. Okay, sorry. I think you were also saying that, and I was just staring at, not understanding. Got it. Okay. Now, what? Why is this upset? Why is there an immutable borrow? Cannot borrow. Oh, I need to tell it that it's mutable up here, right? Wait. Cannot borrow as mutable because it is also borrowed as immutable. No, it's a mutable bar. How do I mutable borrow? How do I mutable borrow? Uh-oh. Uh-oh. Oh, iter underscore mute is what I need to do, is what you're saying. Oh, that's not what I want to do. This shouldn't be iterator invalidation. I'm calling the original thing that I passed in, so like I'm not actually even using, but I get where, okay, I get where this is invalid. Ah, ah, ah. So if this is right, I get it. But I don't have a mutable iteration, which in C++ this would be easy. You just reverse iterate. And I'm just updating the one that I'm on, so this should be safe. But I get why it's not. But there isn't a mutable. Oh, can I just borrow mutable? Can I just do that? Dot enumer. Is that acceptable? No. What was your guested syntax? Yeah, but it doesn't have iter underscore mute. Let me. How am I gonna do this? Iter. Okay, well I can just try it. This isn't telling me that it is a valid thing. iter underscore mute. Yeah, it's not liking that. I put mute here. I think that's correct. I'm not an expert on this though, so you could correct that. Do I need to put a reference on here? Is it like this is something that can only be done via a reference? Not there, but not like that. That's not shift. It does not appear that helps anything. if that makes it anything better. All right, let me Google something. Let's see. How to mutate data usually in a loop. Rust. Oh, is it an at mute? I don't really know what I'm doing here, but this is what I'm going to try. I'm going to throw the at there. And, well, it's now complaining here. Oh, I think it's wanting this here as well. Nope. Some examples. Okay, that's not helping. You're not helping. Not exactly what I'm doing. Oh, I guess we could do like a while. But this has a mutable iterator. Hmm. Oh, so I screwed up the syntax. So you're saying this is wrong. I put the mute here, but you're saying the mute really belongs over here. I don't know why I didn't at. Okay, so what you said the prelude, I just did this, which I'm pretty sure is wrong. So that's probably not. I forgot about preludes. I'm such a dum-dum. I forgot about how people make the preludes with like all the crap that you could use. That was my bad. Why is it not liking this? Let me delete this. Well, it doesn't like that. Doesn't like the prelude. It didn't mind this. Why does it? Doesn't have a prelude. I did not import this. This must have been the editor trying to help me. Okay, let's do I need to do the borrow mutable and then the iterator? Is that like my problem here? Doesn't seem to work that way. Hmm. I can just return a new bitvec and just make a new one and just copy it over. I don't have to solve this, but I was hoping to figure this out for my own learning because we can just do this. Oops. I deleted instead of. We can just do this. And then here we just are going to create our own bit vector. And we can just then return this. All right, so, and then basically what we want to do is if I is less than or equal to 3, we want to do nothing. So actually we want to say if I is greater than 3, that would be the better way of saying this. I don't know why I'm typing random things. Stop it. All right. We are going to do new BV dot set I, and we are going to do I and then x equals whatever the negation of the bit. All right. Solved our problem. Delete this. Return new bit. Done. All right. I know I didn't actually learn why I don't have a mutable, but I solved the problem. Is it not as efficient on memory? It is absolutely not as efficient on memory. Oh well. Now, all we have to do is instead of negate here, we do new BV is equal to what is this called? Custom negate. I know this is really bad. Please don't hate me for this horrid code. I don't know. You can hate me for it. It's pretty bad. This isn't even going to work, is it? I don't need to mutably borrow it anymore. I'm not mutating it. And just do that, right? And let. What do you mean, how's the library called? It's just this right here. I have extern crate bitvec. If you're talking about my TOML, I just did this bitvec equals 0.6. And then I just right here I just did an extern crate bitvec and use bitvec star. Oh, is there a better Bitvec library? Like, if I'm using the wrong one, I mean, I suppose that I'm using the wrong one. I came across, like, I was struggling with so last Thursday this came up, and I didn't know how to use bits in Rust. Like, it didn't, there was no way to do it natively, and so I just found one, and that's what I was doing. I was playing around with today. It doesn't seem to have a mutable iterator, which sucks because that would have been easier, but it doesn't matter. I solved it. I did it. I think. I mean, this looks right to me. I'm just going to do a new one. I'm just returning a new one. That should, I think that should work. Yeah, dude, I haven't touched bits in forever, and basically this has destroyed me. But it's making me learn Rust better than I thought I would have, because it's making me use an external library. It's making me do stupid stuff that you would never do in production, which I kind of like. So I'm not opposed to it. Maybe makes for a crappy stream, because half the time I was sitting here like, I don't know. Seems to work for me. Anyways, or seems to not work for me is probably the better. Okay, anyways, let's see. Let's run this and see what we get. This is a smaller number. 1, 2, 3, 4, 5, 6, 7 integer. Okay, this might be right. I'm having good feelings about this number. Good feelings about this number. We'll see. They think that I'm just guessing random numbers. I'm not. I'm just that bad. I'm just that bad. We've done it. All right, I can rest easy. Thank you for joining me. Thanks for putting up with my Rust suckage. We need a term for that, and I'm going to make a shirt out of that, Rust suckage. Rustlage? My rustlage? I don't know. I'm going to have to think of a word for it that equates to rust suckage or suckage rustage. I'm not sure. Man, I feel like I absolutely suck at programming at all, in general, as a whole. This code, as always, is up in open source. I will hear it. Not that anybody wants it, not that it's useful to absolutely anyone, but it's here. So you know what? Let me show it to you guys. I'll put it in the description of this video. Or, you know what, I won't even change the description of this video. So I'm going to put it in chat. It's right here. Yep, so you can check it out. I'll push today's code. It's not great code, and I apologize for that. But I think we learned something. We learned a couple things, actually. We validated that Merrick didn't know Big Indian versus Little Indian off the top of his head, which way was which. I will take that. I knew what they were. I knew what they meant. I didn't remember off the top of my head which one was which way. So we learned that, and we also learned which way is which. So that's good. Big Indian is when the big numbers are to the left and the littler numbers are to the right, which is, I think, the way that I normally write decimals anyways. So Little Indian is the way that I don't normally write them. So anyways, that's good. And then we learned how to do bit vectors in or bits in Rust. I'm gonna say learned because we kind of hacked our way through it and got something that worked. So I'm happy. Left on a good day, or leaving on a good note. Thanks for joining me. Thanks for putting up with some of that horrible code. I promise that probably as soon as Christmas is done, I'll only do like an advent of code every other week, and we're going to do some Go projects, and we're going to actually do some actual engineering. it's just on my bucket list of things to do is learn Rust, and these are the times that I would do this, and I thought I would stream it, even though I suck at it. Instead of just learning Rust on my own, I'll stream it. Now, I'm also going to make a video, so if you'd just like to see the condensed version, that will be on my actual main channel. You'll probably get to see some of my frustration with this. So, anyways, thanks for joining me. I had fun. Anyways, I will talk to you guys later. Please join me Thursday. We'll do some more Rust. We'll do the second part of day 3 because we only got through the first part. Anyways, have a fantastic evening or morning wherever you are. See you later.